Hey, and welcome back to database-tutorials.com. This is our next video on object-oriented programming with C++, and in this video we're going to talk about character constants in CIN. In our last video we covered some more of the programming basics where we discussed variables, initializing variables, as well as creating comments. So in this video we're going to continue on in our programming basics. So character constants. Character constants use single quotation marks around a character like A and B. Note that this differs from string constants, which use double quotation marks. When the C++ compiler encounters such a character constant, it translates it into corresponding ASCII code. The constant A appearing in a program, for example, will be translated into 97, as you can see here shown in our figure 2.4. This is a variable of type character in memory. Character variables can be assigned character constants as values. The following program shows examples of character constants as variable. So let's build our program here. Here in our int main, what we did was we went ahead and we initialized a character constant variable called character variable 1. We set that equal to a, and then this is our defined character variable as character. And then we created another one called character variable 2, and we set that equal to \t. And then this defines a character variable as tab. And then what we can do is we can do a cout character variable 2, variable 1. This will display that character in the console window. And then we can do a cout on character variable 2, and then this is also going to display that character. And then we can say character variable 1, we can set that equal to b. And then what this is going to do, this is going to set the character variable to a character constant. So we're taking our character variable 1 here. After we defined it as equal to a, now we're setting it to a constant. So it's always going to stay equal to b now. We're renaming that. We're redefining that variable. And then we can do a cout character variable 1. And then this is going to display the character. And then we can cout a new line. That's going to display a new line for us. And then it's going to be a return 0. So now I'm just going to go ahead and build and run this. Yep, go ahead and build that. And now you can see here at the top, A, B, press any key to continue. A as our first character variable, as we can see here in our program. And then what we did was we did a cout on character variable 1, and then we did a cout on character variable 2. And then we set it equal to b, and then we did a cout on character variable 1. Now if you look here at character variable 2, we have a t for tab, so a \t, that's going to define as a tab in our console window. So if you look in our console window, within A and B, there is a tab in between it. So that's what character variable 2 did for us when we did a cout here, was it added a tab there, and then it printed out B here for us. And then after we did another cout on character variable 1, we displayed a new line here, so we created a new line. So we press any key to continue, it'll go ahead and it'll close that out. And that's character variables. Now initialization, variables can be initialized at the same time they are defined. In this program, two variables of type character and character variable 1 and character variable 2 are initialized to the character constants a and tab, as we can see here. They can be initialized at the same time as defined, and that's what we did here. We defined them and then we initialized them by assigning a value to those variables. Escape sequences. The second character constant, \t, is an odd one like \n, which we encountered earlier. It's an example of an escape sequence. The name reflects the fact that the backslash causes an escape from the normal way characters are interpreted. In this case, the T is interpreted not as the character T, but as the tab character, as we saw recently when we built and ran our console application. We saw a tab between A and B. A tab causes printing to continue at the next tab stop. In console mode programs, tab stops are positioned every 8 spaces. Another character constant n is sent directly to cout in the last line of the program. And as we should already know, cout is going to be, new line. Now there are some examples here of common escape sequences. We have \a, that's going to be a beep bell. \b is going to be backspace, and \f is going to be form feed. And we can see some more here as R is return, and then backslash is just backslash, and then we can also do a single quotation mark and a double quotation mark and a hexadecimal notation. Since the backslash, the single quotation marks, and the double quotation marks all have specialized meanings when using constants, they must be represented by escape sequences when we want to display them as characters. So here we have an example of a quoted phrase in a string constant, cout \run spot \run quotation she said, and that translates to quotation marks run comma spot comma run comma quotation mark she said. As you can see here, a backslash followed by what it is that we want to add in within our text, which is quotation marks. Sometimes you need to represent a character constant that doesn't appear on the keyboard, such as the graphics characters above code 127. To do this, you can use the XDD hexadecimal notation representation, where each D stands for a hexadecimal digit. If you want to print a solid rectangle, for example, you'll find such a character listed as .178, which is a hexadecimal number B2 in the ASCII table. This character would be represented by the character constant xb2, and we'll see some examples on this later. But the character variables program prints the value of character variable 1, A, and the value of character variable 2, a tab. It then sets character variable 1 to a new value, B, prints that, and then finally prints the new line, as you can see here. Now let's take a look at input with CIN. Now that we've seen some variable types in use, let's see how a program accomplishes input. The next example program asks the user for a temperature in degrees Fahrenheit, converts it to Celsius, and displays the result it uses in integer variables. So let's start off fresh here. I want to get rid of some of these comments too here and just make my integer main here look pretty clear and clean. This is going to be my default for practices, right? So here in my integer main, we've already got our IO stream set up and our namespace set up. So I'm just going to I'm just going to initialize a variable name int ftmp. This is going to be for temperature in Fahrenheit. And then I'm just going to print some text out on the screen here. Enter temperature in Fahrenheit. And then I'm gonna close that, and then I'm gonna do a CIN, and I'm gonna say ftemp, and then I'm gonna create another variable called ctemp, and I'm gonna set that equal to ftemp minus 32 times 5 divided by 9. And what this is going to do is this is going to say when we build and run this is going to say enter a temperature in Fahrenheit, and then it's going to request the user to input data, and then that data that gets inputted is going to get stored into this ftemp integer variable that was created. And then we're going to take a new variable int ctemp. We're going to set that equal to ftemp, which is whatever the user enters here in CIN, and we're going to subtract that from 32 and then multiply that by 5 divided by 9. And then we're going to see out, we're going to say equivalent in Celsius is, and then we're going to bring ctemp. This is going to be the value recorded, and then we're going to do a new line here. And then this is going to bring in the ctemp variable here that has this value stored in it, which is ftemp of what the user inputted in from the CIM input, minus 32 times 5 divided by 9. So now if I were to build and run this, enter a temperature in Fahrenheit. So let's say I entered in 20. Now you see here it automatically did our calculation for us. Equivalent in Celsius is -6. So I took 20, we entered 20 in, and then it took that 20 and dropped it down in here, and then did 20 minus 32 times 5 divided by 9 here, and that's what CIN did, and then it stored that in a ctemp variable, and then we just displayed it out here on the screen. So that's how that worked. Now let's read on. The statement CIN FTEMP causes the program to wait for the user to type in a number. The resulting number is placed in the variable ftemp. The keyword CIN, pronounced CIN, is an object predefined in C++ to correspond to the standard input stream. This stream represents data coming from the keyboard unless it has been redirected. The pointer is the extraction or get from the operator. It takes the value from the stream object on its left and places it in the variable on its right. So it's going to get the value from the left and place it in the variable on the right. Here's some interaction with the program. Sorry. Enter a temperature in Fahrenheit, 212. If you enter in 100, then this is what you get. CIN takes it and stores it directly in the variable, and then you'll get your result set. Variables defined at point of use. The Farron program has several new wrinkles besides its input capabilities. Look closely at the listing where is the variable ctemp defined, not at the beginning of the program, but in the next to last line, where it is used to store the result of the arithmetic operation. As we noted earlier, you can define variables throughout a program, not just at the beginning. Many languages, including C, require all variables to be defined before the first execution of a statement. Defining variables where they are used can make the listing easier to understand, since you don't need to refer repeatedly to the start of the listing to find the variable definitions. However, the practice should be used with discretion. Variables that are used in many places in a function are better defined at the start of the function. So the cascading operator, the insertion operator, is used repeatedly in the second cout statement in foreign. This is perfectly legal. This program first sends the phrase equivalent in Celsius is to see out, then it sends the value to ctemp, and finally to the new line. The extraction operator can be cascaded with CIN in the same way, allowing the user to enter a series of values. However, this capability is not used so often since it eliminates the opportunity to prompt with user between inputs. Now, expressions, an arrangement of variables, constants, and operators that specifies a computation is called an expression. Thus, alpha plus 12 and alpha minus 37 times beta divided by 2 are expressions, as we can see here with our int ctemp. We have that equal to ftemp minus 32 times 5 divided by 9, and this is an expression right here. Parts of expressions may also be expressions. In the second example, alpha minus 37 and beta divided by 2 are expressions. Even single variables and constants like alpha and 37 are considered to be expressions. Note that expressions aren't the same as statements. Statements tell the compiler to do something and terminate with a semicolon, while expressions specify a computation. There can be several expressions in a statement. Note the parentheses in this expression, as you can see here. Without the parentheses, the multiplication would be carried out first, since multiplication has a higher priority than subtraction, based on order of operations and arithmetic operators. Within the parentheses, the subtraction is done first, then the multiplication, since all operations inside parentheses are carried out first. So if you took any regular mathematics class, then that's something that you should easily be able to understand. When two arithmetic operators have the same precedence, the one on the left is executed first, since in this case the multiplication will be carried out next, then the division. Precedence and parentheses are normally applied the same way in algebra and in other computer languages, so their use probably seems quite natural. However, precedence is an important topic in C++. We'll return to it later when we introduce different kinds of operators. So we just covered the CIN input. We also learned about expressions as well. And we learned how to take all that and print that out on the screen using a new line and the C out, and also our cascading insertion operator. So thank you for watching. If you're interested in our next video, we will be going over floating point types. So head on over to our YouTube channel here at database-tutorials.com and check it out. Oh, and yeah, until next time.